Spot drills not only start the hole straight, but also leave the required chamfer when programmed correctly. In a previous lesson I mentioned the final holes in this example will be tapped holes, which must be drilled before tapping and spot drilled before drilling. Each of these three tools will use a different drilling cycle, also known as a can cycle. This tool path will be for the spot drill. Like all tool paths, the next step is to select the cutting tool. I'll select the Tool tab, followed by the Select Library tool, then Filter. In the tool list, I'll select None, and then select the spot drill as the type. The spot drill should be larger than the outside diameter of the tap, 5/16 in this case. So in the tool diameter section, from the drop-down menu, I'll select the greater than option, and in the field, I'll enter 5/16. Then accept this selection. From the search results, I'll select the 3/8 spot drill and accept this. I'll set the cutting speed to 100 feet per minute, the feed per tooth to 5 thousandths, and enter the comment, spot drill holes to leave a 25 thou chamfer. I'll select the cut parameters, and from the drop-down menu, I'll select the drill/counterbore cycle. This option is for drilling shallow holes, such as spot drilled, center drilled, or counterbore holes. With the drill/counterbore option, the tool will feed to the desired depth in one motion, dwell for the set unit of, and then rapid retract out of the hole. Here, the only option that's not grayed out is the dwell. Dwell means to pause or hesitate. In the case of a drill, dwelling means to remain at a Z depth, usually with the spindle running, for a set unit of time, and dwell is programmed in seconds. The dwell serves an important function when spot drilling. It helps ensure the holes are started straight for the next drill. Holes are spot drilled because typical jobber length drills will tend to wander and not drill straight. The spot drill is a short, rigid tool, typically with a 90-degree point, that does not wander when used correctly. The spot drill will also leave the required chamfer at the top of the hole if the depth is correctly programmed. When calculating the dwell time, it's important the tool not dwell for too long a period of time. If the tool dwells too long, then it may chatter, and in the case of high carbon steels, it can work harden the part from the heat produced. The formula for calculating dwell is the number of spindle revolutions to dwell for, divided by the RPM and multiplied by 60, because the answer must be programmed in seconds. I'll let the spindle dwell for 1 revolution, so the formula I'll use is 1 divided by the RPM times 60. The field where the dwell will be entered is a simple calculator, so the equation can be typed directly into here without the equal sign. I do not recall the RPM, so I'll go back to the Tool tab, highlight it, and press Ctrl+C to copy it. I'll go back to the cut parameters, click in the dwell cell, highlight the value in the field, type 1, divide it by, and then Ctrl+V to paste the value. I'll type times 60 next, and press enter to perform the calculation. This dwell time of 0.06 seconds is not long, but it's beneficial. In the next lesson, I'll explain the linking parameters for spot drilling.